Hello everyone, welcome back to my channel. My name is Dr. Bisayootokiti. Today I'll be taking us through another series of statistics made easy, and it is called sampling. The topic is called sampling, and if you are new here, please kindly press on the subscribe button and subscribe right now, and also turn on your notification button for you to know when I upload new videos. Then also on the notification button, please press all. Don't press personalize, just press all so that you can see all the videos as it comes in. Okay, today, like I said, we'll be looking at sampling. And what then is sampling? Basically, before we look at what sampling is, there are 4 things we need to know. We need to know what sensor is, we need to know what population is, we need to know what sample is, we also need to know what sampling is. That is when we can go into what. Then I'll take each of those points one after the other. One, what is sensor? Sensor is the head count of people living within a geographical place within a specific period of time. Then what is population? Population is the total number of people living within a geographical place within a specific period of time. Then what is sample? Sample is a subset of the total population, and it is used to represent the population. Then what is sampling? Sampling is the method of picking the sample from the population to represent the population. I hope we all understood what I said. So, and before we also go deeper, there is something we need to know. And like I said, sensor, population, sample, and sampling. If we talk about sampling and we are using census is called the complete enumeration method. It means every element of that population has to be counted, head count of every element within a geographical area at a specific period in time. Then if we are not looking at census, it is either census or we call it a complete enumeration method. For students carrying out project research and like that, by the time you get to that point of selecting either a population, a sample out of the population, or using the total population, depending on what you want to use. But basically, most students don't use the total population. They pick a sample from the population to represent that sample. So if it is not a complete enumeration method or the census method, then sampling comes in. What then is sampling? Like I said, sampling is the method of picking a sample from the population. Sampling is also the process of learning about the population parameters based on the sample drawn from that population. Then, instead of studying the entire universe, a portion of that universe can be studied, and that is sample. Then there are processes or procedures to sampling. There are basically 3 processes to sampling. The first one is to know the total population. Once we know the total population, select the sample from the total population, collect your data, and make decision based on the data that you have collected. For example, let me just give a few examples. I can remember, I can still remember that back then in the university, Professor Tokiti used to cite this example in class, and he said, okay, Bisayo, for example, you are making rice on fire, and you want to see if either this rice is parboiled or it is cooked. What do? Do you throw the whole pot of rice in your mouth? The answer is basically no. What do? I pick my spoon and pick a portion of the rice. Either I use my hand to press if it's completely done, or I taste it to see. That's an example of sample that I have not thrown all the whole rice. That is even dangerous. So I just pick a sample of that population, the total rice on fire. I pick few pieces, about 10, to taste if it's done or not. If it's not done, I add more water, put it back on the gas. I come back another few minutes or few seconds to check if it's done. If it's not, I repeat the same process to see if it is done. If it is not done, I add water until it is completely done. The same example goes for beans. I'm making beans on fire. I cannot come to the pot and throw the whole beans, the pot of beans in my mouth. I pick a portion of the beans and test if it is done or not. If it is done, I bring it down from the gas. If it is not done, I add more water to the beans to see that it is completely done. There are many other things we do like that. Let's take, for example, I go to the hospital. I'm feeling feverish, or I'm not feeling so strong, and the doctor wants to decide what is happening to me, or what drug to give me. The first process is to carry out a test. And what does the doctor do? The doctor will write out, do a malaria test, or a typhoid test, or a comprehensive test, or all these tests. And when you get to the lab, what is done? What is done is that a portion of your blood, they don't drain the whole blood in your system. They just take a portion of the blood to know exactly what is wrong in your body system, or even if you have a disease too. They don't cut the whole body up. They have to test to be sure what is happening before they prescribe the drugs and like that. Then also, a businessman place order on materials or anything. The only thing he does is to take a portion of the material to determine the quality of other material that he has bought. Then another thing to know is, what is the purpose of sampling? The first thing is, sampling is not studied because of sampling. It is not studied for itself. Sampling is studied basically to draw out inference about the population, to make a decision about the population. Then also, the value obtained from that study of that sample, such as average or dispersion, are known as statistics. On the other hand, such values for population are called population parameters. Then what are the laws or principles guiding sampling? There are two laws or principles guiding sampling. The first law is called principle. The first law or principle is called principle of statistical regularity. And the second principle says principles of initial large numbers. And what is the meaning of the first law? The first law says, it was derived from mathematical theory of probability, and it says that a moderately large number of items chosen at random from a large group are almost sure on the average to possess the characteristics of the large group. I take again, a moderately large number of items chosen at random from a large group are almost sure on the average to possess the same characteristics of the large group. What do I mean in essence? If we are carrying out a sample, or we are taking a sample from a population, the larger the number we have chosen for sample, the better the results that will represent or showcase what the population is talking about. We said, in other words, this principle points out that if a sample is taken at random from a population, it is likely to possess almost the same characteristics as that of the population. Then the same theory of the principle of statistical regularity is similar to that of principle of initial large numbers, and it is just a continuation of what the statistical regularity says. The principle of initial number says that, other things being equal, the larger the size of the sample, the more accurate the results are likely to be. Every other things are equal, other things being equal, and that is that the larger the value or the numbers that we have chosen for sample, the better the results we are likely to get. It means it's still similar to that of statistical regularity that says moderately large number of items chosen at random from a large group are almost sure on the average to possess the same characteristics of that larger group or that population, while the initial large number says every other things being equal, the larger the size of our sample, the more accurate results that we are likely to get. Then what then are the methods of sampling? There are two methods of sampling. The first one is called probability sampling, while the second one is called non-probability sampling. Probability sampling can also be called random sampling, while non-probability sampling can also be called non-random probability sampling. What then is random or probability sampling? Random or probability sampling means that every element of that population has an equal chance of being selected. Every element of that population has an equal chance of being selected. And for the non-random or non-probability sampling, is just the opposite of what we have said. That based on some criteria or judgments that we have used, that every element of that population does not have an equal chance of being selected. It can be based on convenience. You might have chosen your sample on convenience, or on your judgment, or probably on your instinct. So based on that, it means that every element of that population does not have an equal chance of being selected. What are the advantages of probability sampling? Probability sampling does not depend upon the existence of detailed information about the universe for its effectiveness. Then the probability sampling provide estimates which are essentially unbiased and have measurable precision. Then lastly, it is possible to evaluate the relative efficiency of various sample designs only when probability sampling is being used. But it still has its own limitation. What are the limitations? Probability sampling requires a very high level of skill and experience for it to be used. A very high it means that even the person using a probability random sampling has to have a level of education, has to be educated to an extent, because it requires a high level of skill and experience. Then it also requires a lot of time to plan and to execute the probability sampling. Then also, what are the disadvantages? Okay, I've said the disadvantages. Then now we go to the method of sampling. Don't forget that I said there are two methods basically. One is random or probability sampling. The other one is non-random or non-probability sampling. Then now, under random, what are the types of sampling that we have? Under random, we have the simple random sampling. Then we also have the stratified sampling, we have the systematic, and we have the cluster. I forgot to say something. Under random sampling or probability sampling, it is also further divided into two, and one is called unrestricted, the other one is called restricted. One is unrestricted while the other one is unrestricted. Unrestricted can also be called a simple random sampling, while restricted are basically the stratified sampling, the systematic sampling, and cluster sampling. Then for non-random or non-probability sampling, we have the judgmental, we have the convenience, then we have quotal, we have other ones that I've not mentioned yet. Looking at what simple or unrestricted random sampling means, like I explained earlier, it means that each and every element of that population has an independent chance of being included in that sample. And this kind of method is free from personal bias, and every element of that population has an equal or an independent chance of being included in that sample. And every individual item drawn must be recorded, measured, and returned to the population. Let's take for example lottery, because the best way to explain what is simple or unrestricted random sampling means is through lottering, or we can also use table of random numbers. But let me explain what lottery means. Let's say for example, I have the total population I'm looking at is 100 people or 100 persons, and from that 100 people, I need just 10 people that I want to give my textbook to. For example, I want to give a textbook to 10 students free of charge, but the total population of that class is 100, and I don't want to be biased. What do? I get a small container and write number 1 to 100 for each of the students that are represented in that class. So let's say number 1 is seated like this, number 2, number 3, number 4, number 5 to number 100. So what do? I shake the container together with every number included in the container. From 1 to I've wrapped them so I can't see any of the numbers. I shake properly and dip my hand into the container. I pick one number. I open it for everybody to see. Okay, the first number I've picked is number 10. So it means the person that is number 10 is the first person of my sample, is the first person included in the sample. So it means number 10 is the first person I'm giving the textbook to. I remove number 10 and shake the container properly again. The next number I'm picking is number 5. It means the person that is number 5 is the next person that is taking that textbook. Okay, I shake the container again. The number I picked is number 95. So it means number 95, the 95th person in class, is the third person collecting the book. Then I shake properly again. I pick number 64. It means number 64. I shake again. I pick 85. Number 85. I shake again till I shake 10 times and pick 10 out of the total number of people in class. Was I biased? Of course no, because I did not even know the numbers I was picking, because they were already wrapped. They are already wrapped and dropped into the container. So I can't even know who I'm picking or not. I shake proper, and you can bear me witness that I actually shaked the container to pick. That is an example of lottery. So it means at any point I can pick either 1 to 100. I didn't say 1 and 100. I said either 1 to 100. So it could be 1, it could be 2, it could be 3, it could be 4, it could be 5, it could be 6, it could be 7, it could be 8, it could be 9, it could be 10 to 11 to 100. So it could be any of it. Means that system is free from personal bias. I cannot say I want to wrap, okay, I know number 15 and I want to wrap number 15 in a special way, so that he or she will be qualified to take the test. No, is something that is open and no secret, so that I can shake properly and pick the right people. And don't also forget, I said every element has an equal chance or independent chance of being selected in that sample. Then another way we can look at the simple and unrestricted random sampling is through random numbers, table of random numbers. And table of random numbers are they are techniques that are already done, that you just select the number and pick the sample from. It has its own merits and demerit. What is the first merit? It is free from personal bias. It is free from personal bias. Then another way is that as compared to other methods of sampling, it is far better than other methods of sampling, but it also has its own limitation. What is the limitation? It is the use of simple random sampling necessitates a completely cataloged universe from which the sample is drawn, and that could be quite restricting. Just imagine I have 1 million people and I'm trying to get a sample of 10 from 1 million. It means I have to number every element to 1 million. That's a large sum, and it could be really tasking. Let's say if it's not 1 million, I have 10 million people, so I have to number 1 to 10 million and just pick 10. It could be really tasking. Then the second one is called stratified sampling. And what do we mean by stratified? These are the use of stratas and stratum. And what do we do in this kind of sampling? The first thing is that the population is divided into homogeneous group or classes called strata. Like I said, the population is divided into homogeneous group. Homogeneous means same group, related. We did classification. I've said grouping of related fact into classes. So this population is, the first thing is that it is divided into homogeneous group or classes that are cross stratas, and a sample is drawn from each of the stratum or strata. Like I said, each population is divided into homogeneous related groups or classes, and they are called strata. And a sample, like we did for the first one, a sample is drawn from each of the stratum at random. Then let's take, for example, we want to carry out a research in Kwara State, for example, and we quite know that Kwara State is big. What is the first thing we do? Dividing into strata or stratum is dividing Kwara State into local governments. Then we can now select from that each of the local governments and at random. Then we'll come to a conclusion. It has its own merits and demerits. What is one of the merits? One, it is more representing. The stratified method is more represented because we have to divide into homogeneous group and pick from each of those. Then it has a great accuracy level. Then a greater geographical concentration. Yes. Then what are the limitations? One, utmost care must be exercised in dividing the population into various stratas, because if it is not properly done, then that's a mistake already. Then also, the items from each stratum should be selected at random, or it is difficult to select each item from each of the stratum at random except when it is properly supervised. Then the next sampling method we'll be looking at is called systematic sampling. And like we said, we have talked about simple random sampling, we have talked about stratified sampling. Then the third one is called systematic sampling, and this is one of the most popular method of sampling in reality. And what do we do? The method is to select every k item from the list and then refer to the sampling interval. Let me just explain what this means. For example, we have 1,000 students and we are looking for a sample of 200. We have 1,000 students and we want to take a sample. The total number of students we need from that 1,000 is 200. What do? We divide 1,000 divided by 200. That is what? 5. 200 plus 200, 400, plus another 200, 600, plus another 200, 800, plus another 200. That's 1,000. So 1,000 divided by 200 is 5. So from the first 5 figures, don't forget we are numbered from 1 to 1,000. From the first 5, 1, 2, 3, 4, 5. Pick any value you like from the first 5. Let's say from the first value, the first value you are picking is 2. From 1, 2, 3, 4, 5, because it is systematic. So it is done in a systematic way. So once you pick from the first 5, any value, if you like pick 1 or 2 or 3 or 4 or 5 itself, any value, but I'm picking 2. So since I've picked 2, the next value I'm going to be picking, I'll add plus 5. So the next value will be what? 2 plus 5 is what? 7. The next value I'm going to be picking will be 7 plus 5. 7 plus 5 is what? 12. The next value I'm going to be picking will be what? 12 plus 5. 12 plus 5 is what? 17. The next value I'm going to be picking is what? 17 plus 5. That will give me 22, and like that till I get to 1,000. Like I said, it is systematic, and the method is to select every k item from the list where and refer to the sampling technique. I just made an example, and like that we continue like that until we complete, we get to 1,000. By the time we get to 1,000, we will have seen that we have chosen 200 students for our sample systematically. Then what are the merits? The systematic sampling design is simple and convenient to adopt. That is one of the best merit. It is simple. Once you understand the logic or you understand the process behind it, it is simple and convenient to adopt. Then the limitation, one of the limitation is that this method becomes less representative if we are dealing with population having hidden periodicities. This method becomes complex or becomes less representative if we are dealing with population that have hidden characteristics. It becomes less representative. The next sampling method we'll be looking at is called the multi-stage sampling, or you can also call it cluster. From the word multi-stage, it means multiple stages are used. It could be random sampling combined with stratified and combined with systematic. It could be systematic and random. It could be simple random sampling and stratified method. One method is used at the first stage, then another method is introduced at the next stage with any suitable method that is used, that is helpful. Multi-stage, a multiple stage sampling method. And this kind of what is the merit of this kind of sampling? One, it introduces flexibility to a sampling method. It makes the work more flexible. Then it has its own limitation. What is the limitation? A multi-stage sample is in general less accurate than other form of sampling. It is less accurate than other form of sampling. Then the next thing we'll be looking at are the non-random sampling. I said non-random sampling or non-population probability sampling method, and the first one is judgmental, the second one is convenient, and the third one is based on quota sampling. And what do we mean by judgment? From the word judgment, it means it depends exclusively on our own discretion or that of the investigation. When we say judgmental or judgment sampling, it means that decision to pick people from that population, that decision is directly, or it is with the investigator. It depends on the discretion or the decision of the investigator. And like we said earlier, that every element of this population does not have an equal chance of being selected. It could be due to my own discretion. I decide to use students of a particular university to compare to another university that is farther from me, so based on my discretion. So judgmental sampling is exclusively based on the discretion of the investigator. The second one we'll be looking at is convenient sampling, and convenient sampling is usually called the chunk, and this refers to the fraction of the population being investigated or being selected from my own convenience. For example, I want to carry out a research on undergraduate students, and for example, I stay in Lagos or I stay in Kwara. I don't need to go to Kaduna or Katsina or Ogun to look for undergraduate students, whereas I have people that are very close to me. So it's not based on judgment but my convenience. I can also decide to do a table research without going anywhere, and I'll just call and say, okay, the number of students based on my convenience. Then the last one is called the quota sampling, and they are set up according to some specific characteristics. Thank you all for listening. Don't forget to drop your comments in the comment section below. Ask me your questions. I'll be willing to reply them. Then also, if you have not subscribed, please kindly press the subscribe button and subscribe right now. Thank you.